In this video, we are going to learn how to sketch the graphs using given information about the limits. In our earlier video, we learned how to get the limits from the given graph. You can check the link for that video in our description box. So let's start with this problem. We are given this information about the limits. First, we should write the interpretation of each limit. We should write them in words so that can be helpful in sketching the graph. Here we see that the left limit and the right limit are not same when x is approaching to -2. Graph is approaching to 2 from the right side of -2 and it's approaching to -1 from the left side of -2. That means there would be a break in the graph at -2. So we can write this information here. Whenever you have a limit, when the y value is approaching to -infinity or positive infinity, that means there is a vertical asymptote. So we are going to draw a dashed line over there. We see that limit exists over here and the graph is approaching to the same value 3 from the left side as well as from the right side. But the function value is not same as the limit. That means there is going to be a hole. In such cases, when the function value is not same as the limit, that means there is going to be a hole over there. Now using this information, we can sketch the graph. From the left side of -2, the graph value is approaching to -1. You can draw a curve like this. And from the right side of -2, the function value is approaching to 2. So it can be here. Now look at this point. We are given that f of -2 equals -1. That means this is going to be a dark circle over there. So at -2, it's -1. So this is going to be a filled in dot over here. And from the right side of -2, we can move like this. Or if we are not sure, we should not move further. Let's plot other information and then we can connect the dots. At 1, there is a vertical asymptote. So let's draw a dashed line at 1 to represent the vertical asymptote. We are given the limit as x approaching to 1, y value is approaching to infinity. That means the y value is approaching to positive infinity from the left side as well as from the right side. So we can continue this graph from here like this, and on the right side as well, graph lines always move closer to the vertical asymptotes. Next, we are given that limit exists at 4. That means from the left side of 4 as well as on the right side of 4, function is approaching to 3. Since there is a hole at 3, so we put hole over there. Connect the graph lines like this. This point is given as 4, 1. We can draw a black dot over there. At 4, it's 1. So it's important to draw the dots and the important points, and then you can interconnect them using your own way. Like here, I drew the graph coming downwards on the right side of 4, but someone can also draw the graph coming upward from the right side of 4. So it's not necessary that all of you get the same graph. There are many possible graphs for the given information, but the information about the important points must remain same. They should match. Here is the next practice problem. We again try to get the important information from the given limits. Whenever the y value is approaching to infinity, that represent a vertical asymptote. So there is going to be a vertical asymptote at -6. Next is at -4, limit does not exist. And at -4, there is no function value given as well. So the graph might be disconnected here. For the next part, limit exists at 3 and it is approaching to 1 from the left side as well as on the right side. But the function value is not same as the limit. That means there is going to be a hole at this point. And limit exists at 5. That means function is approaching to 6 from left side as well as on the right side. And same is the case here. That function is approaching to 0 from the left side of 7 and the right side of 7. So graph is going to be continuous at these 2 points. The limit is undefined when x is approaching to 9. That means the graph might be broken here, or we are not sure about the right side of this graph, because graph might be continuing from 7 to 9 on the left side of 9, but we are not sure about the right side of 9. That's why this graph is undefined. So we can stop drawing the graph up to 9 to make it undefined. Using this information, let's start sketching the graph. First, we draw a vertical asymptote at -6, and the graph is approaching to positive infinity on both sides, on the left as well as on the right side. At -4, limit does not exist and the function is undefined, so we can draw a hole over there. Now let's sketch the other information. F of 3 equals 6, so there is a dark circle at 3. Limit is approaching to 1 at the left side and the right side of 3. We draw a hole over there. At 5, limit is 6, and at 7, limit is 0. So we draw those points and try to connect them. At 9, limit is undefined. That means graph might be continuing on the left side of 9, but it is stopped here. Now back to this part of the graph. At -4, limit does not exist, so we are free to draw the graph. This graph fulfills all the conditions, that at -4 graph is disconnected, that means limit does not exist at -4, and at -4 function is undefined, that means there is a hole at -4. In between those important points, you can draw the graph in your own way. You are free to use your creativity in between those important points to draw the graph in any way, but don't forget the vertical line test, which says when you draw the vertical line, it should not intersect the graph at more than one point. For example, if you are drawing the graph like this, it won't pass the vertical line test. So this won't be a correct sketching of your graph. And don't forget to check the final answer, final graph, using the vertical line test.